All right, looks like we might have roughly everybody we're going to have. So I'm going to go ahead and get started. Welcome to a gentle introduction to Docker for Rubyists. Thank you. So I'll tell you a little bit about why I wanted to give this talk. I've started learning Docker a little bit recently myself, and by recently I mean a year or 2 years ago. I just started teaching Docker to myself. My experience with the official Docker documentation and just the general literature for Docker online is that it was really hard for me to understand. Does anybody else have that experience looking at the Docker docs? Yeah, like pretty much everybody, it seems like. And so I found that really tough. It took me a really long time to just make heads or tails of anything with Docker. And then sometimes when I would talk to other people who were already proficient with Docker, they acted like it was easy. And that was really frustrating because it's like, what, am I dumb or something? Like, why can they understand it so easily, but it's like super hard for me? So what I'm going to do today is go like really slow and just start at the beginning of like what is Docker and all that stuff. What are the foundational concepts? Why do people use Docker? And my hope is that I can do a better job of explaining some certain things today than the official Docker documentation does and most of the material online does. I'm going to talk a little bit about format. So, okay, one thing I want to say is that in the past, I've done workshops like this before. I've facilitated workshops like this before, but they've been like workshops for corporate clients where it's like I fly to their office and there's a team of like 10 or 15 or 20 people, maybe 30 people. Never with, I don't even know how many people are in this room, but a lot more than 20. So we'll see how it goes. I think it'll probably go pretty much fine, but this is a much larger group than this type of thing is usually done with. I'll also mention for the people watching the video later, I have low hopes that this will translate great to a watch the video later kind of format. So apologies to the people watching at home. It surely will not be the same, but we'll do the best we can. For format, the way I'm going to do it is it's going to be highly interactive and highly exercise-based. I'm going to do an exercise myself, and then I'll turn it over to you for you to do the same exercise. During the times when you're doing the exercises, I'm going to try to come around the room and kind of check on people and see how everybody's doing. Periodically throughout the workshop, I'm going to try to check in and ask, am I going too fast or too slow or just right? And please help me remember to do those check-ins because sometimes I forget, but those are really important. Working in pairs or groups is strongly encouraged. And so if you want to kind of buddy up with the person next to you and you just work on one computer, I think that's great. In the workshops I've done where people do pair up like that, everything goes a lot better because just the process of verbalizing things with your partner, being like, I didn't understand this step, and then you talk through it together, that helps a lot. And especially with a group of this size where I'm not going to be able to give individual attention to a lot of people, that'll be all the more helpful. Questions are encouraged. If you have a question, feel free to just, I was going to say just interrupt me and ask, but this room might be too big. You can raise your hand and I'll call on you. Or if you want to just interrupt, that's totally fine. Here is the overview of what we're going to do today. And by the way, it's not super important to me that we get through all of this, because what I don't want to do is rush through all of this just for the sake of getting through all of it, because you're not going to retain anything if we do it that way. So we're going to go at an appropriate speed, and if we get done with all of it, great. If we only get a third of the way through, then fine. The important thing is that we actually go slow enough that you can understand and retain some of the stuff that you learn. Okay, with that, we're going to talk first about what is Docker. We're going to talk about the 2 use cases for Docker, Docker concepts and terminology. We're going to do a Docker Hello World. Then we're going to Dockerize a Sinatra application. We're going to add Docker Compose to the Sinatra app, and if you're not familiar with Docker Compose, we're going to go over what that is. Then we're going to add a PostgreSQL database to our application. A little bit about me. I'm the host of the Code with Jason podcast. By chance, are there any listeners in the room? I was just curious if there would be at least 1 or 2, and there are at least 1 or 2. I wrote a small ebook called Docker for Beginners, which came out very recently. It was kind of a product of putting together this workshop, actually. And another book called The Complete Guide to Rails Testing. And then I blog at codewithjason.com. What is Docker? Does anybody feel like they have a handle on what Docker is? They could answer that question. Do I have a volunteer to give me their version of what they think Docker is? A small virtual machine? Okay. That's probably the most common answer to this question. What is Docker? Well, it's kind of like a VM. It's not exactly a VM, but it's kind of like a VM. I think that's kind of the wrong answer because it's the right answer, but it answers the wrong question. Because when people are asking, what is Docker, the question isn't like mechanically, how does it work? When you say it's like a VM, that talks about like how it works, not what it is. So I think a better way to answer this question is to talk about why people use it. What are the benefits of Docker? Does anybody have a feel for like why do people use Docker at all? I'm going to do a lot of these questions throughout the workshop. I'm sorry, can you say that again? Quick dependency setup, yeah. Any other use cases for Docker? I'm sorry, can you say that again?
Yeah, managing different versions of the same software.
Oh, managing different versions of the same software, okay. Okay, so here's what I came to understand regarding the use cases for Docker. It's took me a lot of studying to arrive at this. And I don't know why they don't just come out and tell you in the beginning, but there's 2 use cases for Docker in my perception. One is for making it easier to install and run your development environment's dependencies. And I'll say that again because it's a little bit of a mouthful. Docker makes it easier to install and run your development environment's dependencies. We'll go a little deeper into what that means in a bit, but that's one use case, the development environment. The other use case is for a production environment. Similar deal, it makes it easier to install and run your production environment's dependencies. The mechanics of the production environment are a little different than development environment. There is overlap between those 2 use cases, but they're 2 kind of distinct use cases. Today, we're going to be focusing on the development environment use case. We're going to be completely ignoring the production environment use case. The reason we're going to ignore that is, first of all, there's already a lot of stuff that we're going to cover, and we just can't cover that much stuff. But also between the 2, the development environment stuff is the easier of the 2 to work with and understand and all that. All right, so we're going to get into the exercises shortly, but just a little bit more of this stuff before we get to those. Does anybody know in Docker terminology what a host machine refers to? I saw it nodding. What does host machine mean? Yeah, he said the host is the machine that the container is running on. So we haven't gotten to container yet, but the host machine is just your computer. So if I'm running Docker on my computer, when I say host machine, I just mean my actual laptop. Images and containers, that's a big one. And this will take a little bit to get this across, but here's my attempt at explaining these concepts. So what you're after with Docker, okay, I'm going to say something again that I said before. One of the use cases for Docker is making it easy to install and run your development environment's dependencies. So where do containers come into this picture? If I have an application, let's say I have an application and I've Dockerized my database. I've only Dockerized my database. Why would I do that? Well, that just helps me with one dependency. I don't have to install PostgreSQL or whatever database management system I need to have. I don't need to install that manually. I can just have my Docker config file and have PostgreSQL installed and running. The way that happens is through a container. I will have a PostgreSQL container running on my computer. And so that's what allows me to not have to actually have PostgreSQL installed on the host machine. I can just have PostgreSQL in the container. And then when I connect to the database, I'll give it, just like we would with anything else. We tell it the IP address and the username and password. And instead of pointing at my actual host machine's localhost, we'll point the database connection config at the container. So PostgreSQL is running inside that container. So we'll come back to containers. I don't expect a lot of these concepts to be able to sink in on the first pass. It'll take like coming back to things over and over, just like it took me. I had to read definitions over and over before it finally clicked. And these definitions have kind of intertwined dependencies. So you have to like hear one term and then hear another one, then go back to the original term and like bounce around a little bit before you can understand them all together. Anyway, let's think again about that PostgreSQL container where I have PostgreSQL running. It's like a computer inside my computer that's running PostgreSQL. Well, the way I get there is I have a PostgreSQL image. The image is kind of like the blueprint, and the container is like the house. So the image has the instructions. It says, here's how you make a PostgreSQL container. You don't actually run the image. You just have the image on your computer, and then when you want to run that thing, what you get is a container. So again, the image is like the blueprint, and then the container is like the house. And once again, these things will be a little easier to grasp, I think, once we get into the exercises. A Dockerfile, I almost feel like this is too much stuff before we get into the exercises, so I'm gonna skip over a couple of these. But the Dockerfile is the instructions for an image. So an image is what you can build a container out of. But then even before the image, you have a Dockerfile, which is like even lower level. And for example, if you wanted to make your own PostgreSQL image for some reason, you would have the Dockerfile is like a script. So you would have something inside of the Dockerfile that says apt-get install PostgreSQL or whatever it is. And so that's where the Dockerfile comes into the picture. The last one of these terms I'll go over before we get to the next part is volumes. Containers are ephemeral. You'll start and stop containers. You'll create and delete containers. They don't last forever. This creates a problem when it comes to storage. To go back to that PostgreSQL example, your PostgreSQL database needs a place to keep its data. If you just keep that data on the container, when you stop or delete that container, that data is going to go away. So we can't do it that way. So the solution to that is we have to do storage on the host machine. And we'll see the details of how to set that up. But the idea is that we have this PostgreSQL container. We have the container configured to say, hey, don't store this data inside the container. Instead, we link it back to a certain place in the host machine, and we store the data there. All right, just that much. Would you agree that that much was kind of a lot? Yeah? Okay. Would it be good to skip over and just get started with the exercises and maybe come back to this? Yeah, I'll do that. Okay. Apparently I had individual slides for each of these. The first exercise we're going to do, I think it'll be kind of a fun one. We're going to do a Docker Hello World. Raise your hand if you happen to have a Lisp installed on your computer. You do, Chelsea? You did too? Okay. Well, I'm glad that only apparently 2 people did. I picked Lisp because I figured people are unlikely to have Lisp installed on their computer already. Because here's what I want to convey with this. To me, the magical thing about Docker is you can install and run services on your computer without actually having them installed on your computer. As we'll see with Lisp, we can get a Lisp image, we'll run it and get a Lisp container, we can write some Lisp inside that Lisp container, and then when we're done, if we want to, we'll delete the container, delete the image, no more Lisp, there's no evidence that we ever had Lisp installed on our computer. And I think that's kind of neat, because to use another example, I have a WordPress site on my computer, because my blog is on WordPress. I loathe WordPress, and I don't want to install PHP and MySQL on my computer. And so instead I Dockerized my WordPress website. And when I want to work on my WordPress site, I just spin up the container. I don't have to have PHP or MySQL installed on my actual laptop. And I think that's nice. The other benefit that I should mention is when a new programmer gets started at your organization. Okay, here's a fun exercise. What's the longest it's taken somebody in this room to get your development environment set up? Raise your hand if it has taken you at least an hour. Wait, how long did it take you, Chelsea?
So I was working on a project where we gave up.
Okay, for the video, I'll repeat that. She said she was working on a project where they just gave up. So I guess infinity wins. Okay, raise your hand if it's taken you at least an hour, at least 4 hours, at least a day. I can't, almost everybody still has their hand raised. Okay, at least a day, at least 2 days, at least a week? Okay, that's as far as I'm gonna go. I'm really surprised. A lot of people still have their hand raised at a day or 2 days. So imagine if instead that can be 10 minutes. And not only 10 minutes, but a really easy 10 minutes where most of that time is just waiting. So to me, that's the magic of Docker, is that you can do that. And so my hope with this exercise is to convey that magic to you, and you can tell me after we go through this whether it felt magical to you or not. Okay. So I'm going to do this on my computer, then I'll turn it over to you guys to do it on your computer. First, we're going to add a Docker file. Well, I'll just go over this real quick. It might be that none of this makes sense yet, but we're going to add a Docker file, build an image from our Docker file, run the image, which will create a container. Then we're going to shell into that container. Just like you can SSH into a remote server, you can shell into a Docker container. We're going to start a Lisp REPL inside that container. So just like the Ruby REPL where you can interact on the command line, you can do that with Lisp too. Then we're going to run a Lisp hello world inside the REPL, which is again inside the container. Then we're going to exit the container and delete the image. All right, so I'm going to do this. And I'm going to work out of my own material here. Did everybody get the GitHub repo This will be in your GitHub repo, and if you don't have that, there should be a link in the Discord channel. I'll make this a little bigger so people can see. Is that big enough to kind of see? Make it a little bit bigger. Okay. All right. First, I'm going to create a directory to put my app in. Then right at the root of the project, I'm going to create a Dockerfile. I'll explain what all three of these lines mean. And again, what is a Dockerfile? A Dockerfile is the instructions for creating an image. And I'll say the whole chain again even. A Dockerfile is the instructions for creating an image, and then an image is what you can use to generate a container. All right, so this first line, you can kind of see that this is syntax highlighted. From, run, and workdir are all keywords. So this Dockerfile has its own like special Dockerfile syntax. This first line, from Ubuntu 2004. That's called the base image. So every image, at least that I've ever created, comes from a base image. You can pick, I don't know, for example, you could pick Ruby for the base image if you needed that for some reason, PHP. In this case, I just want Ubuntu, so I'm picking Ubuntu Linux as my base image. And version 20. Kind of the syntax of a Docker image is the name of the image, then a colon, then the version of the image. The Ubuntu 2004 image, that's somebody else's image that's just like publicly available. Somebody else created that and I can just grab it. I'm going to run one and only one command. For a real production application, I'd probably have at least several commands here running, but for this super simple hello world, I just need one. Run apt update and apt install -y sbcl. So let's go by that. Let's go through that bit by bit. I'm actually going to start with the second part, apt install. So how many people here have worked with like the Linux command line installing packages and stuff? How many people have not? Okay, so a decent amount of people have not. With Ubuntu, when you're installing packages, it's always apt something or other. So when you install, you might do apt install PHP, apt install PostgreSQL, whatever. In this case, I'm doing apt install SBCL, which stands for something or other common Lisp. It's just a variety of Lisp. The -y means don't prompt me, because when you install a package, it'll normally ask you like, this will use such and such disk space. Do you really want to continue? And you have to type Y or N. We're not going to be around to type that because this is all automated. So we need to do the -y so it doesn't prompt us. We're just telling it, yes, just do it. And then the apt update, for some reason okay, here's what I think apt update does. Does anybody know what apt update does? Okay, well what I think it does, here's my attempt at explaining it. It makes your system aware of the places where it can get packages and stuff like that. Can anybody explain that better than me? Nobody in this room? Okay. Well, that's my terrible explanation. Oh, okay, you? I'm going to summarize this answer for you. Something to do with caching. But honestly, that part is probably fine to not understand for now. And I apologize for my terrible summary of your very good answer. Okay, so that's the base image, and then the step where we actually install Lisp. This last one, workdir, /user/src. This tells us what our working directory is going to be. It's a totally arbitrary choice. I've gathered that it's kind of conventional to pick /user/src for whatever reason, so I'm just kind of going with what I perceive the convention to be. What this means is that when we shell into our container later and we do pwd, it's going to tell us user src, that's where we are. And anytime we do anything with this container, it's going to put files in user src. That's our working directory. So those are the 3 lines of the Dockerfile. I'm going to do something before I build this image, and we'll talk a little bit about what it means to build an image. First, I'm just going to see what images do I have on my computer now. And the reason I'm doing this is because I want to see the effect. Like, I want to know that after I build the image, something actually happened. So I'm going to check the before state, and then I'm going to take my action, and then I'm going to check the after state. So first of all, what images do I have? I have a lot of them, and so it's hard to read this. So what I'm going to do docker image ls, pipe it through grep hello. Okay, so I have no hello world image on my computer. That's the information that I was after. I'm going to do the same thing with containers. Docker container ls, a bunch of stuff. I'm going to grep hello. Nothing with anything to do with hello. Again, that's the information I was after. No images, no containers that have anything to do with this project. So now we're going to build it. There are 2 arguments to Docker build. Wait, 3 arguments to Docker build. I'm going to start from, wait, hang on. That's 2 arguments. It's 1, 2, 3, 4, 5 individual words, but it makes 2 arguments. Okay, I feel like you should forgive me for being confused. All right, anyway, when you build this image, the rightmost argument, that dot there, that signifies, of course, the current directory. What that's specifying is that saying this is where the Dockerfile is. This is where the Dockerfile is. It's in the current directory. So Docker, that's where you should look when you try to build this image. The other part, --tag lisp. That's another arbitrary choice. We could call this anything we wanted to. And in fact, I'm going to decide to call it something else. You know how I was grepping for hello just now when I was looking for containers? Well, I'm going to be consistent with myself from a second ago, and I'm going to call this hello. So I'm going to say docker build, call this image hello, and look in the current directory for the Dockerfile. This will take a second to do its stuff. You can see there it's doing run apt update and apt install -y sbcl. So the thing that it's doing right at this moment is it's installing Lisp for us. And this usually takes a little bit of time, but not too terribly much. I'll take this opportunity to see if anybody has any questions. Does anybody have an entertaining story? Oh, I saw a hand. I don't know if it was a question or an entertaining story. But did somebody have something back there?
You mentioned that you're running the Ubuntu base image, and you said there's like all kinds of base images you could use. You could use like Ruby. Like obviously Ruby and Ubuntu are not the same kind of thing. So is the Ruby base image like just using like some Ubuntu or whatever, some Linux base image, and then it's installing Ruby, and then they're kind of labeling that like this is a new base image. You can, put that's up in some like repository now.
That's a fantastic question, and that's a question I've had for myself too. Because you're totally right that those two things aren't apples to apples. Ubuntu is an operating system, and Ruby is a programming language. My honest answer to that question is I do not know. But what I'll try to do is, in a break, I'll see if I can find that out and get back to you with the answer.
Thanks.
Yep. Okay, so it appears as though our build has finished. So let's take a look. Before I had done docker image ls, grep hello. Okay, so whereas before we saw nothing, I'm going to clear this. Before we saw nothing, now we see hello. Let's do the same thing with containers. Again, nothing, which is what I expected, because all we did just now was we built our container. Sorry, we built our image. We didn't do anything with the container. So just to restate where we are, we've built the image. We have an image called hello. We have no containers. So now we're going to create and shell into this container. This command is a little bit of a harder one, and I do have to get my image ID to feed into this command, so let me grab that. Okay, let's try to talk about this one a little bit. The command is docker run. And docker run is how, among other things, docker run is how we can docker run is how we can run an image, thereby creating a container. You can see that last argument there is /bin/bash. That's the program we're having our container run. So the reason that makes sense is because what we want to do right now is we want to shell into the container. Because what we want to do is shell into the container, we want to run the program bash, because that's the program that gets run when you want to interact with the command line. So that's why we're doing that. The reason we're passing in the Docker image ID is because it needs to know what image we want to run. The other flags I'm going to skip over, but long story short, that's the way that it doesn't work without those. I'll put it that way. Okay, so now we're in our container. We're no longer in my host machine. This is not my laptop. We're inside the container now. And if I do pwd, remember before when we were talking about the Dockerfile and we had that workdir? I'll bring it up even. We said workdir user src. When we go into this container, where are we? We're in user src. So that's what connects that to that. And if I do an ls, there's nothing here. This container is like a totally empty computer. Okay, and another thing we can do, I'm going to go into a different window here. I'm going to make sure I'm in the same directory. Okay, so we had looked earlier for our Docker images, and we of course found this hello image. And when we did Docker container ls, it brought back nothing. If we do it now, it brings back nothing again. That's surprising. All right, let's see why this is. I'm going to make the font a little smaller because I know everything won't fit. Okay, so I happen to have a lot of containers running on my machine right now, but we can look through. Okay, here, let's do it this way instead. I'm using this image, this 8C87 blah, 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 using that image to run a container. I'm going to do docker container ls grep that image. And there it is. So I think my memory was just bad regarding how these containers get labeled, but the container is, in fact, running. Okay, so our container's running. We're inside our container. What do we do now? We can poke around in this container a little bit. I already did pwd ls-la. We can see it's empty. Who am I? This is kind of interesting. We are root. So if I go back to my host machine, who am I? I'm Jason Swett. But then if I run my container again, who am I? I'm root. The reason I'm doing all this stuff is just to really gain the understanding that this is a separate computer. And it has just everything is different. It's not sharing a file system. The users are different. It's an entirely separate computer. Now, the grand finale of this exercise, at least, where we run the Lisp REPL. So we can do this sbcl command. And now we're in the Lisp REPL. Here's a Lisp hello world. Who's ever written any Lisp before in this room? Okay, a few people. The syntax probably looks pretty weird if you're not familiar with Lisp, but this is a hello world, and it prints out hello world. So we just ran some Lisp on a computer that doesn't have Lisp, which I think is pretty neat. Now I'm out of my container. My container's no longer running. I do still have this image. This hello image. I'm going to delete it. I'm going to do docker rmi-f, then the image ID. RMI means remove image, and -f means force. Okay, so now my image is gone, which I can prove by doing docker image ls grep hello. It gives nothing. So just to quickly recap, we went from not having Lisp to we used an image to install Lisp, but not really install Lisp because my computer doesn't have it. Then we removed the image, and we're back to where we started. So I think that's pretty cool that you can do that, and you can imagine all the things you could do with that. Question in the back. How do you close the REPL? Control D. Be really careful when you're in the Lisp REPL. If you type anything other than the exact thing that you're supposed to type, disaster may ensue. It happened to me. It was really bad. Okay. That's my portion. Now it's time for you to do it. Did anybody just actually follow along in real time? Okay. Like almost everybody? Did anybody not follow along in real time who would like to do the exercise now? Yeah, okay. Let's if you already followed along in real time, then great. But for those who haven't and you want to go through it, let's give us just as much time as it takes to go through it. It shouldn't be all that long, and I'll kind of come around and help. Can the people who are starting the exercise now, can you raise your hand just so I know where to walk around to? Okay. I don't know why I did that. There's no way I'm going to remember who you are. But I'm going to walk around, and if you would like me to take a look or give you any tips or anything like that, just grab me. Okay. If you don't have the repo and you're not on Discord, you can search for GitHub JSON Swett and go to my repositories, and it's the RubyConf 2021 workshop. Okay, so I become aware of two facts. One fact is that we've only gone through a small fraction of what I intended to go through. The other fact is that we're almost out of time. So I think I'm actually going to end it here with the exercises, because this was, at least, even though it was only a little bit, it was kind of complete in the sense that we did one whole exercise, so I don't want to start a second one. I have been asked to go over some of the terms again and also include some of the terms that I skipped over. So I'm going to go over those, and then you're free to go. So let me pull those up. Oh, this clock says 6 minutes. How much time do I have left? Oh, I'm good? What time is it now? Oh, wow, okay. All right. I guess we have time for another exercise. Yeah. All right, so I heard a couple people say that this is like actually helpful, so that's good to hear. Because honestly, I don't know, yeah. So here's what we'll do. Normally when I do like corporate workshops for clients, we'll like take a break partway through. So let's do this. I'm gonna go over some of these terms again, then we'll take a break. Let's take a 5-minute break.
Hi, so I just had a question, because I've worked at a couple of different companies now that use Docker with Kubernetes and that sort of thing, and they do some pretty complex stuff with it, but they don't implement the development side of it, like using it to do development on the platform. And I was just wondering if you had seen why there's that resistance, or why people don't do it more often, that sort of thing.
That's a good question. So let me make sure I understand the question. Where you work, they use Kubernetes and they use Docker for production purposes, but they
Right.
don't use Docker for development.
Right, and even at the previous company, they do that too. So they use Kubernetes for the orchestration and getting it running in production and stuff like that, but they don't really develop on it, so you have like the same platform that everybody uses and that sort of thing. They tend to develop locally and then, push the code to the Docker image and that sort of thing.
Got it. Okay, that's pretty interesting, and I actually hadn't heard of that way of doing it until now. Does anybody else work somewhere where they only use Docker in production and not in development? Okay. Okay, so apparently it's not unknown. And does anybody know why they do it that way? Oh, okay. Well, yeah, but it'd be a pain in the ass to debug in production and development, so that doesn't seem like it could be the reason for only doing production. Yeah, in the back. I think I get it. So I think what I heard was that sometimes somebody might they might get production Dockerized, but then by the time they get around to getting a development Dockerized, it's maybe much more difficult, and they run out of time, they can't make that a priority, that kind of thing. Is that kind of the gist of what you said? Got it, okay. Yeah, it may well be that, well, it's certainly the case that some development environments are easier to set up than other development environments. And in a production environment, you don't have all this stuff running on the same machine. Like in development, you have like PostgreSQL, Redis, Elasticsearch, all that stuff running on your local development environment. But in a production environment, you have your web instance or whatever, and then you have a separate PostgreSQL service on AWS RDS or whatever. You have separate Redis service, all this stuff. And so even though the whole picture of Dockerizing a production environment, I think, is harder, at least it was harder for me, the Docker part of that whole picture can be simpler, if that makes sense. Because you still have to, there's a lot to Kubernetes and all that stuff, that's hard to learn, but the actual Dockerized application is simpler than the Dockerized development environment. So that's kind of a guess, but that's my guess. Okay, we're gonna go over these, then break. Host machine. Again, that's your actual computer. Images and containers. Did anybody not understand images and containers before, and they feel like they kind of understand images and containers now? What would you say if somebody asked you now, what are these images and containers all about? Does anybody feel like they could articulate that who wasn't able to before? Yeah. Yeah, so I think that was good. He said the image is kind of like just a snapshot. It's this static thing. And then the container is what's generated from that image. So again, the image is like the blueprint, and the container is like the house. And you can use one blueprint to make multiple houses. You can bulldoze the houses if you want to, build them again, all that stuff. But the image is like this static thing. Dockerfile. The Dockerfile is the instructions for creating an image. As we saw with our exercise, we wanted this hello world image, and we had those 3 lines in our Dockerfile that specified how we wanted to build that image. Okay, volumes. Again, containers are ephemeral. It's a hard word to say, but containers are ephemeral, and you can't do storage on your containers because your containers go away. So you connect your container back to your host machine and say, hey, instead of storing this stuff in this directory, store it on my host machine. And you can kind of sync up those two things and say, when something changes in my container, reflect that change on my host machine so that it can persist even when I kill my containers. We didn't talk last time about Docker Compose or Docker Hub. In order to talk about Docker Compose, let's talk about applications versus environments. You've probably heard people talk about Dockerizing an app. But the way I think about it is you don't really Dockerize an app, you Dockerize an environment. So when I talk about, your application has these dependencies like a database management system, Redis, blah, blah, blah. That's not just your application, that's your whole development environment. So the thing that you're Dockerizing, again, is not just your application, but your whole application's development environment. Your development environment is usually composed of several services. That's where Docker Compose comes in. You'll have a config file separate from your Docker file where you say, all right, Docker, I have my application, like let's say we took our Hello World Lisp application, we have that one. I want a database for it, a PostgreSQL database. I want Redis, and give me that environment. And when you start up Docker Compose, it'll look at your Docker Compose config file and say, okay, I see your custom app, I see your PostgreSQL database, and I see Redis. Let me grab all that stuff, I'll get it all installed and get it running. That's what Docker Compose does. And some of our subsequent exercises will make use of Docker Compose. Docker Hub is a place where images can be publicly hosted. So it's kind of like GitHub, but applied to Docker. In our original Docker file for that Lisp Hello World, the base image was Ubuntu. When I specify the base image is Ubuntu 2004 or whatever, it will go out to Docker Hub and grab that image. So when I said somebody else created that image and I'm just using it, that's where that comes from. Somebody put that image on Docker Hub, just like people put open source projects on GitHub for everybody else to use. Okay, let's take a break and reconvene in 5 minutes. Okay, time to resume. So the amount of time that is left is probably a lot less than the amount of time it would take to get through this next exercise. So here's what we're going to do. I'm going to go through this next exercise, which is Dockerizing a Sinatra application. If you want to follow along with me as I do it, then great. I don't think we're going to have time to do the thing like we did last time where I do it and then you do it afterward. So if you want to do this, try to follow along synchronously if you like. And then after this, I'm not going to do like a Q&A thing from up here, but after this, if you want to talk about any Docker stuff, I'll hang out here for a little bit maybe afterward. And then, of course, anytime later in the conference, we can talk. And by the way, your questions help me because I like write blog posts and stuff, and I like need ideas for things to write about. So I need to know what kinds of questions people have. And a lot of times I don't know. And so don't feel like you're like taking up my time or anything by asking me a question. It actually helps me just as much as it helps you. Okay, with that said, I'm going to get started with the Dockerizing a Sinatra application exercise. So if doing this Lisp container thing was a Docker Hello World, then doing a Sinatra app is a Dockerized web app Hello World, with the difference being before we just installed Lisp and that's all. For this, we're going to have an actual web application that we can visit in the browser. Okay, so doing this is going to require us to use, oh wait, sorry. Forget the thing I just said about going to require us, blah, blah, blah. Let me go to the part of the PDF where we have the instructions for Dockerizing the Sinatra application. Okay, so first I'm just going to create my directory where I'm going to keep the Sinatra app. Okay, and our application is going to have just one file. It will be called hello.rb. If you've never used Sinatra before, the way this works is we just have mappings of paths to methods. So when we get to the root path, that's line 3, get slash. When you get to the root path, just return the text, it works. And that's what will show up on the page. So that's like our main application file. We also need a gem file that installs the Sinatra gem. That's all there is to that. I did that fast. This just has a single gem, Sinatra. Okay, and there's this rackup file. I don't really know what the deal is with rackup files, but we need it, so I'm going to add that. It's not really super pertinent to the Docker-related stuff. Okay, so first I'm going to do the undockerized version of this app, just to show you what we're after. So I'm going to do a bundle install. That will, of course, install the Sinatra gem. Run Ruby, hello.rb, and you can see here it says listening on 127.001 port 4567. Let's go there. It works. Thanks. That's an inappropriate large amount of applause for what happened. Please don't do that again. Okay. Okay, now we're going to Dockerize this application. We're going to create a Docker file, and by now you know what Docker files are about because we had our Docker file for that Lisp application. This one has a little bit more to it. We'll go through this bit by bit. So first line, what is this called? When we have from blah, 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 what's the name of that thing? Base image, correct. Workdir/code. What's that all about? Somebody needs to say it like louder. That's what will show up when you SSH in, and that's what shows up when you SSH in because that's where it keeps all our code. We have this extra thing on line 4. We're saying our working directory is /code. Now copy all of our files into /code. We didn't need that before because our Lisp Hello World thing, we didn't have any files that we were dealing with. The difference here is that we do have some files. That's why we need the copy command. Another new one, line 5, run bundle install. With run, you can just put any arbitrary command after it, like any arbitrary Linux command or whatever. Here we're doing the bundle install. Expose 4567. That means expose port 4567. If you go and learn more about Docker after this, one of the things that it will help you a lot to learn about is Linux networking. A lot of the times when people say, I don't understand Docker, Docker's too complicated, what they don't realize is what they really mean is they don't understand Linux networking or they don't understand Linux file systems, because a lot of these concepts are just Linux concepts, and Docker just kind of stitches it all together and orchestrates it for you and that kind of thing. So Linux networking is something that's really helpful to understand. Anyway, we're exposing port 4567. We have this weird looking command. What this is there's kind of a guideline with Docker where you have one process per container. Is anybody unfamiliar with the term process? Like when we're talking about Linux and stuff like that, processes? I'm going to say it anyway because I don't believe you. I'm sure at least one person in the room doesn't know about processes. So a process is just a program that's running on your Linux machine. And so there's a one-to-one relationship. You could have more, but I understand it's a good practice to have kind of one process per container. So for this container, our process is this Sinatra application. It's in this weird array syntax, but here's what this really just is. It's that. It reduces down to that. So we're saying bundle exec rack up, which is like if you're going to run a Sinatra application, I think you run rack up, and then we're telling it, this is some Linux networking stuff that we don't have time to get into, but like the 0.0.0.0 thing, that translates to 127.0.0.1, and again, we're saying port 4567. Really, the important thing to understand about this last line is what runs the Sinatra application server. Okay, and we're going to do another thing that we did in the last exercise, so this will be a little bit familiar now. We're going to build our image for our Sinatra application. So I think I called my last one hello, and I don't want some kind of naming conflict, so just let me Docker image ls grep hello. Whoops. Yeah, okay. I don't think we're going to have a problem. I'm going to build that. Side note, a lot of people traveled for this conference. Also, it's daylight savings time. Did anybody else wake up at a crazy time this morning? Yeah, I've been up since about 3:45 a.m. Yeah, no, that's fine. That just means I'll go to sleep at 4:30 p.m. tonight. Okay, our image is done building. And now we're going to run it. Okay, so this run, again, is a little bit different from how we ran our Lisp image. Before, we just said run it. This time, we have to give it a little bit more info. We have -p 4567 colon 4567. The reason we're doing this might sound kind of weird, but the 4567 colon 4567 says, take whatever's running on port 4567 in the container and surface that on the host machine at port 4567. So it seems kind of funny that we're saying the same number twice, but it makes sense because we're like mapping this port to this port. It just happens to be the same port. When we run that, we see the same output that we would see if we were just running a Sinatra app natively. I'm not seeing the indicator yet that it's running at localhost blah, blah, blah. And it's taking longer than I would expect. Let's see what happens when we just go to 127.4567. Oh, it works. I'm always skeptical, like, okay, this doesn't seem like it would work, but it says it works, and I don't believe it, so let me do this. I'm going to kill the server. I'm going to refresh the page. Okay, site can't be reached. I'm going to start the server again. Oh, I didn't even have to refresh it. That was kind of weird. But another indicator we can see, okay, see how there's like 2 lines here right now? It says get HT blah, blah, blah. If I refresh a couple more times, okay, we see more lines. That's more evidence that what we're seeing is the same thing that we think we're seeing. Because it's really easy just in general to get fooled into thinking, like here, do we know it works because our Dockerized thing actually works? Or did we make a mistake and our native Sinatra app was still running or something like that? Okay, so that is it for the Sinatra application. So hopefully, you know, that Lisp application, we saw the magic of being able to run something on your computer that you don't actually have installed on your computer. And then with this, I wanted to take it one step further, just a tiny incremental step to see how we get from that like hello world level thing to actually having a web application running. So if you want some homework for after this, first of all, you can take that PDF and work through it. But like the Docker and Linux networking stuff, I think is really helpful to understand when it comes to web applications. Anyway, thanks for coming here to do this with me. I hope that you understand Docker a little bit better now than you did before.